This is the video solution to practice problem A that accompanies sample problem 3.5. This problem appears on page 88 of your text. This problem has two parts. First, we will calculate the number of atoms in 7.31 moles of potassium, and then we will calculate the number of moles that comprise 8.91 times 10 to the 25th atoms of potassium. Let's begin with a very basic equality. We know that 1 mole is a defined number of particles. The number of particles is Avogadro's number, or 6.022 times 10 to the 23rd. In the case of potassium, 1 mole of potassium would be equivalent to 6.022 times 10 to the 23rd potassium atoms. This is an important equality in that it applies in the same way to any type of atom. 1 mole will be Avogadro's number of atoms. If we needed to, we could also include the mass in this equality, but the problem that we have before us right now only asks us to look at moles and atoms. Now, as we solve part A, we will start our dimensional analysis with the value 7.31 moles. We'll need to cancel the unit of mole, leaving the unit of atoms at the end. Using our basic equality that's shown in purple, we can place 1 mole in the denominator of our conversion factor so that moles cancel. 1 mole is equivalent to Avogadro's number, so 6.022 times 10 to the 23rd atoms will be in the numerator of this conversion factor. Moles cancel, and the multiplication that we're required to do to give us a solution results in 4.402082 times 10 to the 24th atoms. This value is going to have to be rounded to 3 significant figures because our initial measurement, the 7.31 moles, only contains 3 significant figures. Therefore, we will record a final value of 4.40 times 10 to the 24th atoms of potassium for this problem. For part B, we'll begin the dimensional analysis with the value 8.91 times 10 to the 25th atoms of potassium. The units of atoms will cancel if we place Avogadro's number in the denominator of our conversion factor. We will then place 1 mole of potassium in the numerator. Those two things are equivalent to one another. This time, we'll do some division, and when we complete the required math, we find a value of 147.9574 and some other digits moles of potassium. This value must be rounded to 3 significant figures based on our starting measurement, so we'll have 148 moles of potassium at the end. At this point, please take some time to complete practice problem B in this group and check your answer with the key on page 115 of the text.